Okay, hello everybody. Happy New Year. I hope you can hear my voice. I have like to start it now. So today is January 6th and this is the 43rd episode for a Houdini Algorithmic live. This is a live tutorial for Houdini that I've been doing weekly, and I'm changing the topic for every week, and the topic for today is to create a point plotting out of a shaded 3D geometry, and as a final result I'm going to place the plotted points on a flat plane, so that I can bring it to any other softwares for other purposes. I mean, for me, I wanted to use it for a printing, so that's kind of the reason why I have projected on the plane. So I'm gonna show you how I did this based on a precision method. So what you can do is you can change the direction of the light, the camera directions, and so on. If you go right here, it is originally come from this 3D points, and if you look at this from a different kind of angles, it really looks like a point cloud from a LiDAR sensor. But if you use this camera, which I'm using this camera to project the point, then fix the camera positions with this lock, then you can recreate the point plotting with that certain camera angle. Okay, so I guess this is not really for the animation, but I found this, fun, so I'm gonna show you how I did this thing. Okay, so let's do that from scratch. Okay, I am going to bring this up, a new window. Okay, so first of all, let's try to bring up some geometry that I would like to plot a point onto. So first of all, I'm going to create a geometry node. Oops. Okay, my text geometry. I'm gonna start with a really simple geometry like sphere. So sphere, or maybe maybe having a bit complex geometry might be better for initial testing. So yeah, I'm gonna do with the rubber toy now. Right. So first thing I need to do is to make this geometry as one object, one continuous solid object. Hello everybody. Happy New Year. To do that, currently I think this is split it into several parts, like the body and the legs. So I'm going to combine all these together as one solid object by using a VDV. So VDV from polygons. And then set the voxel size to small enough so that I can see the shape. Maybe 0.02 may be fine. Then convert it back to a polygon using convert VDV with the polygon option. And now I would like to also show the edges. Okay. Now, next thing I would like to do is to create a floor, because I also want to plot the shadow on the floor as well with the points. So darker the shade is, the more dense point cloud that I want to create onto a geometry. So let's create like disk floor. So I'm going to create a circle and make this XZ plane and set the size to some bigger than the original this space geometry, so probably like 5 might be too big. 4, 3, yeah. Well, let's keep this to 5 for now. Okay, and next thing I would like to do, since I'm going, well, first thing I'm going to do is to apply an attribute to each of the point on a mesh, on a polygon, with a shaded value, like if it's dark or a light, based on the light direction. So more resolution you have for meshes will be great. So for this disk, there is not much points inside this disk, so I'm going to remesh it first. So remesh. And I am not seeing any edges here. Guess I don't know why. Okay, I think I need to make this polygon. Okay, and let's also set the divisions to a bit higher so that it looks circular. Okay, good evening. And let's also set the target size for this remesh to be a bit smaller, like 0.1. It really depends on the resolution you want. For my setting, maybe this is better, but it depends. Now the face is, the normal direction is facing downwards, so I'm going to make this facing upward by making a reverse to the circle so that all the points normal is facing upward for the surfaces. Okay, now that's good. Now next thing I'd like to do is to, for each of the object, for the floor and the 3D object, I'm going to set the group for each of them with a different name for some purposes later on. So for the first group, I'm going to name it as floor. For each of the point. And for the object, I'm going to name it as, say, object. Right, and then I am going to merge them together. Before doing anything else to this, okay, I think I should lift the object a little bit up so that it will stand on the disk. So I'm just gonna go back here and raise this value up a little bit. Okay, maybe just a little bit more. Something like this. All right. Now, next thing I would like to do is to set some initial attributes to each of the point for a floor and the object, and that is going to be the minimum distance between the points and the maximum distance between the points. So for the floor, I'm going to set the maximum distance to be really big, because outside the object, I mean, has to be I want the distance between the points to be really big, but for the inside where we have the shadows from the object, I want to have the point distance to be really small as possible. For the object itself, for the shadows, small as, to get the distance between the points small as possible is good, but for the other parts, I want to set some smaller size than the maximum size of this disk. So that's kind of a reason I'm separated all those two objects together to set the different values for the range of the point distance, and that is going to be plotted on top of each of them. So I'm just going to use a point wrangle to apply two different attributes to each of the floor and the object. One for the floor min max and one for the ground. The object min max. Okay. Now for the floor one, what I'm going to set is the float attribute min. Let's name this min t size, meaning minimum target size. CHF min t size, and I'm also going to apply the maximum target size to that attribute, float attribute for each point, max t size. Okay, let's copy this one and promote so that I can have those parameters, and paste this same code to the object min max and also promote the parameters. Now I'm gonna set the different values for the floor and the object. So let's have this null controller to have all the parameters that I want to control later on. Okay, and I'm going to open up the editor interface, and then let's name min target mesh size or edge size, whatever. Min target mesh for the floor. So let's say min floor target size. Min floor target size. And I'm gonna duplicate this, and this time it's gonna name it max floor target size. Okay, duplicate these again. This time a min object target size. Okay, min object. This one is the max object target size, max object target size. All right, now let's also set the ranges. So for the minimum, I'm going to set the minimum to really small, so let's set it to between 0 to 0.1. Same for the object, 0 to 0.1. And for the maximum distance or maximum distance between the points, I'm going to set it the maximum to 5. Same for the object. Okay. So, and initially I am going to set the minimum distance to be something like 0.03. Same for the object, and for the floor maximum distance I'm going to set it to something like 4, and for the maximum object distance I'm going to set it something like 0.5. Maybe I'm going to change it later on, but let's go with this for now, and I'm going to copy one of it and paste it right here. Okay, and I'm gonna paste this again and rename this. So for this one, this should be a max floor. All right, now going back to the control, and let's copy this one. Then I'm gonna paste reference right here and right here, and rename this min to max. Okay, so that is for the preparation for the geometry, and also let's create some information to control the direction of the sunlight. Now I might be able to retrieve the sunlight direction using the real sunlight object, but I'm gonna make it simple. I'm just going to create a line. to use it as a sun direction. Okay, so currently it's going upward. So first I'm gonna set it -1, and I'm just gonna set random values for now. So maybe I can just use this one to control the angle interactively. So let's see, something like this. So this is going to be the sun direction. Maybe later on I'm gonna make this parametric as well. Let's keep it as it is for now. Now, after I have created the line direction, which is going to be used as a sun direction, then I am ready to create a shading information on top of this geometry. I mean this one. So let's do that. Okay, so to do that, for each of the point, I am going to set an attribute to set the shade in between 0 to 1. If it's 0, it's darker. If it's 1, it's lighter, based on the light direction. And probably, if I could, I would like to also use the light camera direction to create some Fresnel effect as well, to make it more, to have some specular effect. But for now, let's try to do with the lighting, the directional light. So it's going to be like a pseudo directional light. And I'm going to make the calculation to set the shading really simple, since we're not dealing with the shaders here, we're dealing with the geometries. Okay, so I have created the point wrangle, and let's set this to lighting. And let's write some code here. So first thing I would like to do is to retrieve the direction from the second input. So I'm going to retrieve 2-point position from the second input. Since this is the line, there's only 2 points. So okay, has to be from the second input. And the first point is going to be the starting point of the line. And the second point is going to be the end point of the line. Then you can calculate the direction by subtracting those 2 vectors, and then let's normalize this as well to set the size of this vector equal to 1, right? Now this is going to be this direction of the sun. Now what I want to do next is to calculate the dot product between the normal direction of at each of the point on those geometries, then use that dot product to use it for a shaded value. Okay, so that's what I'm going to do. Let's do that. So float dot value is equal to dot product between the normal direction between the direction. Now if we use the dot product, if the direction is facing at the same direction, then you get the value equal to 1. If the direction between the normal direction and the sun direction is opposite, then the exact opposite, meaning 180 degrees opposite, then you get -1. So the range between the range of this dot product value is from -1 to 1. So to make it in the range between 0 to 1, I'm going to use the fit function to remap. So dot value is equal to fit the dot value, which is currently in between -1 to +1, and then I'm going to convert it into 0 to 1. All right. And let's try to have a attribute called color and set this dot value to this color attribute, float color attribute. Then I am going to try to visualize this color attribute using color node with an option ramp from attribute using col. Okay, now I think this has to be an opposite, or maybe I can make this range opposite. If it's -1, then I'm gonna set it to 1.0, and if it's +1, then I'm gonna set it to 0. I'll turn off the default lighting by pressing this button here, disable lighting, so that I can see the procedurally created shade. And maybe for now I'm going to disable the line. Now it looks okay, but it's a bit too light on the backward, because since these places are not going to be lit by the directional light, these places should be really dark. So I think I gotta control that. So to do that, what I can do is to, well, since this is where I can, okay, so first of all, the dot product gives you a value in between -1 to 1, and if it's -1, if I look at the object, and if it's this is normal and the sunlight is like this, and then comparing with the sun direction with the normal, the dot product of this value is going to be negative. Okay, and if the normal direction is like this and the sun direction is like this, then this is going to be positive, or dot product is going to be positive, and for this one, dot product is going to be negative. So if it's negative, it has to be lighter, brighter, and if it's positive, it has to be darker. So what I want to do is to clamp this value when it's positive to make the backside really dark. I mean, currently I'm setting the shade so only the place where the normal direction and the sun direction matches, it becomes black, and for the other one it creates a gradient, the gray gradient, so from black to white. All right, but I want to set some limit where this black part have more part covers more part of the geometry, like right here, or half of the geometry. To do that, I am going to use a clamp function to change the range of this dot val beforehand. So what I'm going to do is to dot val and use the clamp, and dot val is in between -1, which is the brightest part, and to 0. Okay, so this means is that the back half of the geometry is going to be really dark. I mean, it's going to be covered by a black shade. And then since I have changed the range from -1 to 0, I'm going to change this range from -1 to 0 as well, and see how it change result. It looks like these. Okay, so now if we also look at the direction of the light, you can see that it corresponds with the lighting direction. Maybe I should move this a bit upward. Doesn't really matter where the position is. Okay, you see this? So when the dot product becomes negative, or I mean the positive, then the color becomes whole black. And this should, the direction should changes based on the direction of the sunlight as well. Okay. So this is also a simple concept how the shader works for the lighting. Okay, seems to work. Okay, now I might want to control the range of the black part. Currently I have set it as half, so let's set it as parametric, which is right here. So CHF, let's say dark, and have this value copied right here as well. Okay, now so that I can control the range of this black part like this. Okay, now I'm gonna keep it for 0 for now, since it looks okay to me. Alright. So next thing I would like to do is to maybe I can also bring these. The next thing I would like to do is to have some more contrast between the black part and the white part. Currently the whole place where the dot product is negative is a bit too bright. It looks a bit too bright, and all the positions which is positive looks a bit too dark. So I want to have a bit more of a gradient between the darker place and the lighter positions, the attributes. So to do that, I'm going to have a additional calculation for this dot product value, which is to calculate with the power function. So like square root or root square, calculate with the squares. Let's see how I can do that. I'm going to update the dot val again. And power. And I'm going to use the dot val. CHF. And let's see. Let's name this to sum power. Okay. Now if it's 1, you have the same result. If you make this larger, you have more of a gradient, the gradient contrast. Like these, if it's between 0 to 1, you have high contrast. Like this. Okay, so let's set the range of this sum power to say 0 to 5. So that I can be able to control the gradient. All right. Okay, I have a question. Doesn't the fit also clamp out of range values? I'm not sure. I mean, normally it doesn't in other programming languages that I have tried. But let's see if it does. If I disable this one. Okay, so this does seem to clamp. So I guess in Houdini the vex would clamp. Not sure. Let's see. Because it depends on how this fit function implemented, and we don't know how this being implemented. So I thought it would be safer to use a clamp beforehand. It seems like the color is in between 0 to 1, so seems it's fine to use without the clamp. Yeah, so I guess it's okay, but I'm gonna make it short to be able to have it. Okay, just in case you want to implement it in other languages. Right, now next thing I would like to do is to have some Fresnel effect with the camera, so that I would be able to have the outline of this geometry to have a little bit of lighting effect, just like having the backlight effect. Okay, so it's going to be really a fake light that I'm going to calculate. So let's do that. I mean, it's not really necessary, I guess, but to make it a bit more interesting lighting effect, I would like to have it. So to do that, I need to have a camera direction information, and currently I don't have any camera set to this scene, so I'm gonna create one. Gonna click this camera and click this button right here to lock the camera direction, so that the camera will follow with the views. Right. Now what I would like to access is the direction of this camera, so let's go back to the code right here, and to access to the camera direction, camera transformation, I am going to use a function on Vex called first of all, use the OP transform to get the matrix, the transformation matrix of the camera, then retrieve the direction by using a crack transform functions. So let's do this somewhere in between right here. So first of all, I need access to the camera, so let's create a camera path first. Cam CHS Okay, I have a question. I don't have background related to coding. Can I still learn Vex? Well, I did created the series called Vex for Algorithmic Design in this YouTube channel. I think you can look at the playlist that I've created for this channel, and I think by looking at it, you'll be able to learn the basics of Vex coding, even without the knowledge of programming. So I guess you can start from there if you would like to start doing it, even if you're a beginner on the programming. Okay, so now that I have a cam string, what I want to do is to access to the camera directory, I mean the object, which is this one, so ///cam. All right. Now what I'm going to use is to retrieve the transformation matrix from this object, camera object, and you can do that by using a function called OP transform. Okay. Now the input, for the input I need to input the node position, and then as an output you get 4x4 matrix. I'm gonna name this cam matrix. All right, so and out of this transformation matrix you can get the directional vector by using a crack transform, and use the TRS translation, rotation, and scaling order together with the pivot position to 0. Then cam matrix as a last input. And you'll be able to get a vector value, which is going to be the cam direction. And I think it's not normalized, so I'm going to, or maybe it's normalized, but make sure let's make this normalized if you want to use it for the dot product. Right. If it's not normalized, then the result of the dot product is not in between -1 to 1, but it's going to vary. So to be able to use it with a range between -1 to 1, it's always important to make the direction normalized. Okay, so I'm going to calculate the other dot product, another dot product between this camera direction and the normal direction of the object. So float dot val 2 is equal to dot normal cam direction. Okay. Now let's try to visualize this dot val 2 directly with the color for now to see how it looks like. It doesn't look that much difference, so I'm gonna change the range of this one dot val 2 to fit, and what was it, -1 dot val 2 -1 to 1 to 1.0 to 0.1 0.0. Okay, so you see that you have a bit of resonance effect already. So this is what I want to use, but currently it's a bit too gradient, too smooth gradient. I want to make the light edge to appear just the white edges to appear just on the edges. So most of the places I want to make it really dark. So to control the gradient, you need to have another power functions that I have already done right here. So I'm gonna copy these one and do the same calculations for the dot value 2. So I'm going to just delete this one, dot val 2, and let's change this to, I guess this is okay with the 0. Okay, and for the power, I'm gonna name this cam power. Okay, looks good. Now that I have this value here, if I increase this, okay, I think something is wrong here. Let's see. I am not sure. Maybe I didn't need to have a fit or clamp for this dot value. Maybe I can disable this one. And let's set it to right here. Oops, has to be positive. Okay, and if I raise this up, okay, it's not that bad, I guess, but maybe I would still need a clamp, so I'm gonna make this back. So I'm gonna undo it several times. Oops. What I'm going to do is to change this minimum value Let's name this Frez, and this to a cam power. All right, now promote these. Okay, I think I need to make this val.val2. All right, now something has happened. All right, now it's darker on the edges, so that's not what I really want, does it? And this Fresnel value doesn't seem to work properly, does it? Nope. Only this cam power is working. Okay, let's see. That is because I'm not using .val2 right here. Okay, now let's see. Okay, so this can control the range of the edge light range, and I can also change the the brightness between of these lighting effect. Let's see if I'm doing correctly. Okay, I might want to change the range. Maybe I would like to set this Fresnel as a minimum and set this one to be maximum. So something like this, so that the white part will be much brighter. Okay, so this looks much better. All right. So let's set the range of this cam power to something like 0 to say 15. The Fresnel is from 0 to 1. Let's see how this value will change. Okay. All right. So that I can now control the brightness on the edge. And what I want to do now is to combine these two values, the .val and the .val2, to set the shade. Now I'm just gonna make it really simple. I'm just gonna pick the brighter value in between those two values. So I'm gonna create the variable called col and use max function to get the brighter value between two values, which is a bit of fake as a lighting, but that's fine. We're not creating any shaders. All right, now it looks like these. And by changing the camera direction, you can also change its Fresnel position. All right, looks good. And let's try changing the sliders and see how it affects. Okay. All right. So, so far so good. Now, currently, I guess you can see that there is one place or several places that looks weird. One is that you don't see any shadows on the ground, and there's no self shadows as well. So without it, it's going to be, it doesn't really look 3D when you have multiple objects and plotted with the points. So what I'm going to do next is to create a simple raycasted shadow on a surface, even with the self shadow, and all done in Vex. All right, so that's what I would like to do. Now to do it, it's pretty much the same as I did for the Pseudo lighting. What I'm going to do is to for each of the point on the geometry, like say for the flow points and the points on the sphere, I'm going to calculate the direction using the sun direction. Like let's say this is the sun direction, and using the negative direction of the sun, I'm going to cast a ray like this to that direction, right? And then as soon as you find any intersections on other geometries from this point, then that means this point should be covered by a shadow, right? So, but this one is not covered by a geometry. It doesn't hit with any geometry, so this doesn't have any hit. So that it means it is not covered by a shadow. You can see through with this sun direction. So by doing it, you'll be able to define these places on the floor as shadows, and if you have a self-intersect or self shadows like these places should be shadowed as well. Okay, so that's how I am going to estimate which point should be covered by a shadow, which point should be black. Alright, so I'm gonna do it right after calculating the call. So since we are right now inside a point wrangle, we can just do without any filters. So let's create intersections from each of the point with the sun, the negative direction of the sun. What I need is the intersect function. To use the intersect function, you need to first have two output values. One is the intersected position and one is the UV. And then you can get the intersected primitive number variable named as inter, then use intersect function. And the parameter that I can use is, there are several types of parameters. What I could use is, I guess this one, geometry, or maybe not this one, geometry, the point where the intersection starts, the direction, which also has the length, and then the output parameter as an intersected point, and UV. So 0. The point position that's going to start the intersection or cast the ray is P, but I don't want to use the P as it is, because if you are trying to create a cast array from the point position somewhere right here, and if you start the ray from here, there is a chance that it's going to touch with the same point. So what I'm going to do is to move this point a little bit toward the negative sun direction. And the sun direction was, what was it called? Deer. So deer multiply by 0.0001. So move just a little bit outside the point direction, I mean to the sun direction, so that it won't touch the same point. Now I'm going to create a direction, negative sun direction, which is going to be used to calculate the intersections, and I need to have enough length so that I can check whether the line or ray will be intersected with the geometry or not. Currently the size of this one is around like 2 or less than 2, so having 1000 is enough, I think. It depends on how much the size of the object you have. Okay, and as a output parameter, you can say enter P and UV. Alright, now what I want to do is to only if I have any intersection, then I want to set the point color to be black. So if enter is negative, meaning if you, I mean, it should be positive, I guess. If it's positive, then it means you have found the intersection. So that is where you want to multiply this color by 0 so that it will be black. All right. So I think it did become black. All right. The shadow looks a bit low res, but it's not a problem because we're just going to use it for point plotting. If you want to have more smooth shadow, you just have to raise up the resolution of the ground plane. But I'm not gonna do that. Okay, I cannot see the shadow that much, so let me change the direction of the light. Now I have turned the camera lock off so that I can freely move around using the camera Fresnel at this direction. I can always go back by going into right here. Right, so let me change the sun direction so that I can have a shadow somewhere like this, something like this. Okay, going back here. Now, let's see. Yeah, it looks like these. All right, a little bit to the depths. Okay. All right. Maybe that's good. We can change this later as well. Okay, let's bring the camera back. And maybe I might, okay, need to lock this camera. Okay, now everything is good in terms of the shade. So next thing I'd like to do is based on the shaded value, I'm going to create, I'm going to remesh this geometry. And using the point from this remesh geometry, I'm going to use that as a point plotting, a plotted point. So the remesh is the most important part on this process. Okay, so to remesh based on the color value here, the shaded value here, I need to have I need to set some attributes derived from this color value, which is in between 0 to 1. And each of the floor and the object has the different range for the mesh target size. So I am going to set the size for each of the geometry with those range informations, and I'm gonna just do it inside this wrangle right here. So after I have set the color value, I'm going to also set the attribute called target mesh size using fit to fit the color, which is in between 0 to 1, to a min t size to a max t size, which I have set it previously right here for each of the object with different values. Okay, now it became 0 for. Okay, I guess this is not linked, does it? Okay, let me go back and copy this one and paste it right here. Okay, now make sure everything is linked, and I'm also going to check the geometry spreadsheet if I have these target mesh size attributes set for each point. All right, looks good. Okay, I have a question. How did I learn Vex? well, by doing some tutorials, I guess. Yeah. Which was on YouTube or Vimeo. And what's next? So that I have set the target mesh size. Next thing I'd like to do is to use the remesh to use the target mesh size attributes. To do that, I'm going to first set the shading to the wire shaded. Then also change this edge length to adaptive. Now I am also going to open up this control attributes and check this mesh size attribute so that I can use this target mesh size as an attribute to change the edge length of each point on a geometry depending on this attributes. Now you can see that it's the edge difference. I mean let me unlock this one, and if I look at right here, you can see that there is a bit of gradation between the smallest edges right here and the largest edges right here. It gradually changes from small to big. Now it does create a smooth gradient point cloud, but if you don't want that, you can control this gradient, how much these the contrast of this target mesh size will affect the target size, the real target size. You can control that by changing this gradation sliders. So if you set it to 1, you have more contrast between the smaller one and the larger one. I'm gonna go with this one for the default, but might be better to parameterize this as well. So I'm gonna go right here and set the gradation float value, which is in between 0 to 1, and keep this as 1. Paste it right here. Now let's also promote some of the parameters that I've set here to a controller. Now I'm gonna open up this and uncheck for a bit linking, and then bring this one. What was this for? Sun dark threshold. Sun dark threshold. Some power. And this is a Fresnel threshold. Okay, and cam power, or it might be better to say fres power. Okay, so apply and accept. Now let me see if I can change those. If I change those values, how it would affect the remesh. Okay, now it's a bit hard to see that. It's because I am having these color values. So what I'm going to do is to delete this color attribute at this point. So I actually didn't really need to color this geometry because I'm just going to use the attribute. but I just wanted to use that to check whether the gradation looks fine or not. So I'm going to use the attribute to delete the point color. Now I be able to see a gradation of the edges. All right, and make this back to the original camera position. And that looks okay. Now, what I want to do next is to just delete the faces and just keep the points. And use the delete node and delete the faces, but keep the points. Now there is, as you can see, there's one problem here. One is that you can see the backside of this geometry. There's, of course, there's points on the backside. So what I need to do next is to delete the backside points or backside faces. Okay, so that's what I'm going to do first. Next, and to retrieve the retrieve the backside geometry from the camera direction, you can do the same process that I've been doing, which is to use the dot product between the camera direction and the normal of the primitive face in this case. So say this is a 3D geometry, and if the camera is looking at this direction, and this is the back side that you want to delete, right? This is the front side you want to keep. And this, the only points you want to plot is the one that's on this front side. And those on the back side, you want to delete it. So to determine if whether this object is on the back side or on the front side is to check the normal direction and the camera's dot product. That's how you can do it. But maybe not. Maybe that's not a good solution. Yeah, that might not be a good solution after all. Because there is a chance that several object is there's a chance that you have several objects overlapping in the same direction. So even if you have deleted the backside of each of the object, like these, you can still see the points right here from this direction as a backside. I mean, this point side has to be covered right here, so I want to also delete those parts as well. Make sense? Same for these part as well. So what you want to show is only the part which is not covered by the front object. Alright. So to do that, dot product is not enough. So what I need to do is do another intersection testing. So use this camera direction as a ray cast for each of the point. I mean, not the camera direction, but what I'm gonna use is the camera position, point position. Then between the point position to each of the point direction, point position on the object, I'm going to create a line, which is going to be used as a cast, ray cast, and create a really long ray cast like this. Okay. And or maybe not this direction, but maybe better to raycast in an opposite direction. So at each of the point position on an object, I'm going to raycast this line, which goes to the camera positions. Okay. So as soon as you find an intersection in between the point position to the camera positions, that means this point is covered by the front side, so you want to delete it. But if you didn't find any intersections between this point and the camera positions, then this point is at the front side, so you can use you can keep this as a front side. So that's how I'm going to determine whether the point should be deleted or not. Right? So let's try to do that. So let's what I'm going to do is to create another point wrangle somewhere around here. Okay. So point wrangle and first thing first, I need to retrieve the camera position. So I'm going to do the similar stuff that I did to retrieve the camera direction, which was right here under the lighting. I'm gonna go back here to copy the necessary information, which is these. Okay, so I'm gonna copy these. And paste it right here. Access to the camera path. Now I have retrieved the camera matrix, and what I'm going to do here is to use the other parameter for the crack transform to retrieve the position of this from this transform matrix. Now there is a option to use the output parameters for the translation, rotation, and scaling. So to do that, we need to have a empty vector value for translation, rotation, and scale. And you can use the crack transform as a void function. Crack transform 0, 0, which is going to be the order of the rotation and the order of the translation, scaling, and rotation. I'm gonna set it to 0 as a default value, and the pivot position to be 0. And what I'm gonna crack is this camera matrix, and as an output parameter, I'm gonna output translation, rotation, and scaling. Okay, and the one that I need is this translation, which is going to be the position of the camera. So I'm gonna use this to first of all calculate the ray between each of the point on the object to this camera position. So you can just do that by subtracting camera position by current point position. Right. Now it's time to calculate another intersections. So like I did before, I'm going to first create an output parameter for the intersection point and the UV, and calculate the intersection using intersect 0 at P plus. Same for this. I want to move a point a little bit out toward the camera direction with the normalize T direction multiplied by a really small number. Okay, I'm sorry. Forgot to change the screen. Okay, well, I was writing it right here. Okay, maybe I should just redo it. Sorry for that. So what I did was going back to the lighting and copy this part where I have created the camera transform. Then paste it right here on the new point wrangle after the remesh. Then promote it and set the camera path. Same as I did for the lighting. Then in order to retrieve the camera position, instead of using this crack transform parameter, I'm going to use the other type of parameter set to retrieve the translation value, which is going to be the position of the camera. So first I need to have a TRS, which is going to be the output parameter for the crack transform, and 0 0 set 0 0 0 cam matrix and TRS. Right. Now I can now calculate the intersection. First of all, I need to have a ray between from the point position to the camera position, which is going to be this one. So vector t dir is equal to t minus at p. It's going to be the ray direction together with the size, necessary size. And then I'm going to create two output vector values for the intersection function. So intersection position and the UV. Then same as I did for the lighting, I'm going to calculate the intersect. So at P plus normalize the direction multiply by really small value, and then to the t direction with enter P and UV as an output parameter. Now what I only need is this inter value, whether to check if it's negative or positive. If it's positive, which means you have found intersection, that's the point where you want to delete. So if inter is positive, oops, what's this? Then remove point. Okay, did it work? I cannot see it because I'm looking at from the camera view, so I'm going to unlock the camera view and see. Okay, nope, it's not removed. So let's see why. I am going to check this inter value with apply to the attributes. Okay, everything is -1, meaning nothing is being touched with anything. So I think I did something wrong here. Okay, first of all, let me check if I have got the camera position correctly. So for the T value, okay, looks like I did. Yeah, looks like I did. And for the point position, which is going to be T minus 1. Yeah, that's also correct. And then enter P and UV. Okay. Let me make this a bit smaller. Enter P. Wait a minute. Well, I think this should be correct, isn't it? But doesn't seem to work. Let's see. V T direction. Am I getting the right value here? Yeah, I think I do. But let me see if the direction is facing to the position where I want. So I'm gonna make a marker to check with the vector value. Okay, Now it does look like so. Okay. Looks like it does. So the intersection value is correct for those inputs. Now I guess something must be wrong here. Intersect 0 starting from and at P normalize P. Okay. All right. Okay, it's not intersected. And I am not sure why. Since it has to be. Oh, okay. I just enable this one and re-enable this one, and now it seems to work. I don't know why. But now it seems to do what I want it to have. So it's deleting the backside, which is being intersected. Okay. Now that's good. Now let's also make sure to delete the backside of the geometry as well. So I'm still going to use the dot product to determine the backside of the geometry. So for that, I am going to use the same things that I did for the lighting. Use the camera direction together with the dot product of game objects normal direction. So camera direction can be retrieved like this and calculate the dot product between the normal direction and the camera direction. And if the dot val is negative, then I also would like to delete it. Oops. Okay, what is wrong here? Reference to undefined value cam dir. Okay, capital D. Okay, now it should do the necessary job. Now let's go back to the camera position, see what will change if I changes the camera position. Okay, looks good. All right. Okay, now it's time to delete the mesh to just retrieve the points. Okay, now there's one problem here. As you can see that you see these points on the edge of the disk. Now that is because the remesh doesn't make the size of these edges bigger, even though the mesh size for these edges is set to really big. This remesh just keep the original point position of the unshared edges. So we don't want to have these ones, so I'm just going to remove the edge after I have done all these stuff right here. So to retrieve the edge, what I'm going to do is to set the group for the unshared edge somewhere around here, maybe after doing the remesh with the group node set it to points, unshared, and disable this one, and enable keep in background bounding. No, not this one. What was it? Include by edge and unshared edges. Now it only select those unshared edges right here. So after I have done all these, I think I still have these unshared edge grouped. So I'm going to delete those points. Let's see, for the point group, unshared edges. All right. Okay, now start to look better. Now, at this point, the point cloud that I want to create is already being created, but currently it's still on 3D, like a lighter point cloud. So next thing I need to do is to make this projected on a flat plane, and that's the last thing that I'm gonna do. Now I don't like the contrast right here, so let's control this a bit. Okay, so let's set the sun power, sun threshold, camera threshold. Maybe the sun direction is not that good after all. Okay, somewhere right here. And let's see what it looks like. And you can control the maximum distance between the points for the geometry by changing this one, the max object target size. If I set it to 0.3 or maybe 0.2, you see that the bit distance became a bit closer. For the minimum, let's set it to 2.025 for both of the floor and object. Maybe for the floor 3 is fine. All right. Okay, now let's try to project these points on a flat plane. Now to do that, I still need a camera direction or a camera matrix. So, and that's going to be a bit of matrix transformation, but there is a useful function in Houdini to project it on a plane from a camera view, so I'm gonna just use that. So point Rango again, and let's name this project or flatten. Okay, and I again need a camera informations. What was this for? This was. So I'm going to retrieve the camera information right here, copy this and paste it right here, and promote the channel to set the camera path again. Now, first thing I could do is to use the function call to_ndc, which can be used to transform its point position to a normal device coordinate, which is in between 0 to 1 for both x and y on a flat plane. All right, so let's do that first. The aspect ratio is, although is loosed, I mean it's going to be destroyed, so we're gonna make this the aspect ratio back again after using this. And now we can use this together with the camera information or the object transformation information. So I am going to just input this camera path here to the first input, and as an effect, I'm going to transform this current point. Okay, now if I do that at somewhere in the space, I should be able to have this kind of projected point. Now, next thing I need to do is to, since this has a depth information, I'm going to set the depth to 0. Okay, now it becomes flat. Now, next thing I need to do is to change the aspect ratio of this one, since currently this is 1:1, but I would like to change it based on the size of the camera, the resolution size of the camera. And I would like, so I do need to retrieve the size information from the camera. So let's have those parameters: width and the height. Okay, and for the width, I can go back to the camera, go to the view, and copy these resolution values for the X value. Come to this width, and for the height, I'm going to rename the res X to res Y. Okay, and I am going to calculate the aspect ratio by dividing width by height. Then I'm going to multiply the X value, X coordinate of this current point, by this aspect ratio, so that the projected value become as looks exactly the same as the one that I have seen from the camera on the perspective view. All right, now I think all is good. Where is it placed? Let me show the grid. Now currently it's on the XY plane, so I guess that's fine. I mean, if you want to place it on the XZ plane, what you can do is to set the Z to minus at P dot Y, and for the P dot Y I can set it to 0, so that it will stand on a plane. All right. Maybe I can scale this up a little bit because the size of this one is close to 1, so it's a bit too small, I believe. So I'm gonna multiply this by 100. And that's it. Okay, now let's see, by changing the parameters, what if I could change those flattened projected points. So first of all, what was this? So sun direction, sun dark threshold, 0 is fine. If I make this sun power too small, you have less contrast, you have more. If you raise this up, you have more gradient. Yeah. If you have Fresnel threshold, to make it bigger, you have a bit of lighter effect on the edge, which is not that visible in a point cloud. So maybe I didn't really need this one. Okay. And if I change this gradation value, you slowly have more smooth gradient point cloud, just like this. So looks more like a blurred shaded view. If you have more something like that, it might be better having this gradation close to 0, but I'm gonna keep it to 1. Okay, and you can control the max floor target size to control the floor density, or you can also control the maximum for the floor to make the shadow part of the floor a bit less dense, and so on. Okay, well, let me look at the comment. I wanted to ask you, is there a way to print values from a variable in Vex to be used later on? Kind of the reverse way of what you're doing with camera with height, width and height. Reverse way of using parameters: set variable in Vex and exported it to control as a parameter. Is that possible? Reverse way of using parameters: set a variable in Vex and export it to controller as a parameter. Okay, I see what you mean. Well, I mean, if you still want to control on a channel, it might not be possible, since using the Vex way, what you can do. Well, let me see. Let me check the Vex function, okay? If there's any things like that, but I don't think there is something like that. I think in order to do something like that, you need to use a Python. But for the Vex, you can only access to the channel. And while you can access to a attribute which has been created by Vex from a parameter, like using an expression like point, primitive, or detail, but if you do that, you can no longer control the sliders. But if that's what you want, that works. But to set it as a parameter value, I don't think is possible from a Vex directly. I think. Now maybe if you want to do that, I mean, I can show you a way to do that in Python. Let's see if you have a channel like test parameter for a float and name the node as null. And what you can do is to I'm gonna check the parameter, I mean the function. First of all, I need to retrieve the node for the from the past. So node okay, and then I can change the parameter of the first I can get the parameter. Okay, I guess you don't really need to use Python then. Yeah, exactly what Stefan Walsh is saying. You can use the expression in the channel, but in that case you cannot use the controller, so there is some downside of it. Well, let me try to see how you can do that in Python. I mean, maybe you don't want to use Python after all, but node. Param test. And then I think you'll be able to set the parameter value. How did I do that? Set set, I don't know, using some custom values. Oops, I don't need a semicolon here. Okay, I think I have some errors here. Subnode object has no attribute param. Oh, right. Okay, so this is not called param, but it's called parm. And yeah, so this is how you can, I guess this is how you can do that. Well, you can refer to the vex attributes from the Python, so it's a bit of you cannot all done in vex, but if you really want to do something like that, you can have Python in between to get the attributes from the vex and then use that to change the controller value. That might work. All right. So and well, what I wanted to do is to use this for the printing, right? So the last things that I tried after this, after creating this point, is to bring this to something more 2D print friendly platform or the softwares like the CAD drawing softwares. So to do that, to bring the only the point geometry to those CAD drawing software, or maybe to the Illustrator, it might be better to use a Python node to export these point information as a text file or CSV, and so that you can open it in any kind of softwares. I mean, the point itself cannot be exported as a geometry, I think. There might be some format you can export the point itself, but I don't know what was it, so I used the Python node to export it to as a text file so that I can use it anywhere else. So first thing I did is to retrieve the geometry information, the point information from the geometry node, geometry class, using the Python. Then for each of the point I'm retrieving the point coordinate x, y, and z and add it to a string as I'm going to use it as a text file and text a string value, and retrieve the point position from the point class. And what's name was position, and you can retrieve the x, y, and z coordinate out of this position vector 3D class in Houdini. So I'm going to convert it into string, each of the coordinate to string, and separate it with the comma. Right. Then I also need the new line here, so but for the last for loop, I don't need a new line, so I am going to create the conditions. If di is less than length of bts -1, then I am going to keep adding the new line, which is \n. Okay, same as you do in Houdini, I mean the vex. Now that I have the values that I can export, I am going to create a text file using the Python's basic function. But before doing that, let's also retrieve the file name as a parameter. So I'm going to create a parameter for the file name. Let's use this file parameter here. Let's name this like CSV file. file. Okay. And to refer to the parameter, I can use the node.eval param. What was the name? CSV file. And this is the path. I can, okay, let's go back to the parameter and let's set this to write only. Okay, so that I can use this toggle to set the directory and set the name of the file that I'm going to save. I'm gonna name it to test.csv, save. And then now that I have a file path, I can use a function from Python using open to create a new file with the W option, write option, then file.write this value that I have just created and close. All right, now let's see if it did work. If this did work, I am going to check the folder, and here you go. All right, so bunch of points being translated into a text information now. Now I can use something like Rhino that I use always for drawing. To import the point information, I'm going to use a Grasshopper, which is another visual programming language for nerve-based geometries, which is also a good one. And I am going to create a file path to set this test CSV, and then I'm going to create another Python node right here, and let's name the input as file, set this to string. Basically, I'm going to write the similar stuff that I did right here on the Houdini. I'm using the same Python, so I'm going to use the same function that I have here to read. Oops. Okay, this happens. All right, let me look into the temporary folder where it should have the crashed file. Okay. This seems to have happened a lot to me. Okay, nope. No, I don't see any temporary files being created, so I'm gonna reopen this one. Wait a minute, not this one. Meanwhile, I'm going to update this. So the copy didn't really work. So let me reopen the file. Open it. Nope, didn't open. Okay, what I wanted to do is to just copy these. Don't crash. Okay. Right, now doing pretty much the same. Just gonna rename this to file, which corresponds to this input, and change this to R since I'm just reading the value, and gonna output as file dot read lines. Oops. Read lines. Okay, didn't work. File read lines. Okay, I don't know capital letters. Now I'll be able to retrieve the point coordinate as text file within Rhino, within Grasshopper. So I can just use another split those information to XYZ coordinate, like split, text split with the comma, and then invert what was the flip matrix, and then simplify, explode data tree, much output, construct point, and you'll be able to see the point plotted on other types of software. Now, because the XYZ axis is different on the CAD drawing softwares, I need to change the X, Y, and Z, and also make this Z value negative to match with Rhino. All right. Nope. Maybe I should do this right here. Okay, I think I'm doing something wrong here. Or maybe, yeah, I think this is correct now. So now, since this is a CAD-based drawing software, it's more print friendly. So I can use this for to draw anything, any nerves, curves, to use this to draw these points. Okay, so that was my workflow. All right, hope you find this interesting. I mean, it's not much complex things that I'm doing here, but I think the idea explained here is useful in some cases, even though you don't want to have those kind of plot points. So I hope you find these helpful for some aspect. Now, let's try with other objects, shall we? If we guys are still here, I'm going to use the switch node to switch the object between different stuff. Keep the floor as it is, but instead of the rubber toy, let's try to use other geometry like sphere, polygon, and let's bring this sphere upward by a half size of this sphere. Change this, and is it really on the ground? Let's check. Nope. I think I need to move up by 1. Right, and let's go back to C. the point. All right, looks good. I like it. Now let me just delete it. And let's change some parameters like the Fresnel threshold. Yeah, I like this kind of a in-between contrast, which makes this a bit more cheerful. Alright, now if you go back to Rhino and refresh this, you can instantly read these point value to use it for printing. Yeah, works just fine. Or like use it together with the Voronoi, might be also interesting. Nope, maybe not. Okay, let me also try with the other one, like some sample geometry, like test squab. Let's also bring the squab up a little bit. Let's check. Okay, well, this is what it is. This is what it is. Maybe there's too much shadows on bottom. All right. So that's it. That's pretty much it. And thank you for watching. I would like to end the live stream here. I am going to keep this as an archive so that you can watch it later. Okay. Okay, so thank you for watching. I have also a Patreon page myself. You can go from the video description if you like to. If you feel like you can support me, I would really appreciate it. And I'm also going to upload the file that I have just created to the GitHub and paste the link to this video description page so that you can download it to use it for your purpose. Okay, later. Okay, after I have finished this streaming. Okay, so thank you very much and hope you guys are having a good happy new year. And would like to see you next week as well. Hopefully you will be able to join next week as well. Okay, so have a nice day and good night.